Welcome to the presentation of Group Number 1. We created a state-of-the-art AI. This AI will not only create a poem automatically, but also write it down in Chinese calligraphy style and read it out clearly. Now, I will introduce our project for the first time, and I hope all you guys can enjoy it. Our presentation has 6 parts. We will first introduce the overall workflow, then demo the program. After that, we will explain how we achieve such a great program in parts 3, 4, and 5. Finally, we will look forward to seeing what we can do in the future and see thanks to some companies and people that provide help in making the program. The first is workflow. To write a poem, the user must provide a title. Poem AI will generate a poem and save it in a TXT file. Then, Font AI will generate calligraphy words and save them as images. At the same time, these words will send to the Xunfei server and generate speech with a beautiful voice. Finally, we arrange the word images and combine the speech into a video and display it on the UI interface. This is a requirement to run our program. You might install them first. Then, without further ado, let's go to the demo part.
After Guanfang's introduction to our project, here comes Min Kai and I will show the demo of our project. The demo is actually a program running on Unity. This is the start scene. We could see there are some buttons and input boxes. On the left, the 4 input boxes are to type in necessary parameters to generate the poem, including the title or the theme, the poem type, the generating method, and the length. Oh, of course, if you sometimes don't want to type in so many things to get a poem, we have prepared for it by setting default parameters. Then you will just need to press the start button on the right. Now I will show an example. I specify the theme and the length. Our theme this time is Big Data.
"非明辨大地千层，草暗文回也暗横。是把金针比例长，敢言只忧愿深思。"
Okay, now let's turn to the poem. As the poem goes through natural language processing, word vector and RNN are applied. First, let's focus on words. One-hot encoding is a common method of expressing words. However, there are more than 500,000 words in Chinese. Apparently, using one-hot encoding to process data will lead to the curse of dimensionality. To solve this problem, we adopt a way based on word vector, aka word embedding. Apart from that, it can also reflect the relationship between words, as you can see in the picture. Words of the same kind gather with each other, and the distance between them is relatively small. As we all know, the complete library in 4 sections is the largest collection of text in pre-modern China. So we use it as a corpora to obtain printing vectors with different properties and use them for downstream tasks. We found a Chinese ancient poetry database which contained 10,000 ancient poems in total to train our model. Poems are stored in 10 files respectively, and 1,000 in each JSON file. Each capital is a JSON object. Besides, sliding window is a good choice to perform required operation on specific window size for time series data in a long sequence. Compared with SIGNN, RNN has a memory function. As the figure shows, x1, x2, and 2xt represent the sequence of input word vectors. FW is a function to calculate new hidden layer based on the current input xt and the previous hidden layer ht-1. H0 is a word vector initialized with all 0. H1, H2, and 2ht are hidden layers. Each hidden layer contains information about all previous word vectors, and RNN will output information of all hidden layers. But there are problems of gradient vanishing and gradient explosion at the same time. To solve the problem, we choose LSTM to improve the performance. The FW is more complex, including cell state and hidden state. Let's look at this picture. The upper line represents the side state, and the lower line represents the hidden state. What's more, 3 gates are designed to affect the lower line by the upper line when predicting time series data. In the end, the model took 10 hours to train on RTX 2080 Ti. From the result, it shows that our model works well. Eventually, the loss value is down to close to 0.
After training the model, we can use it to generate several types of Chinese traditional poems by applying the possibility table of words. As we can see, 3 kinds of poems are shown in this slide. The first one is poetry mood, which plays one of the most important roles in ancient poems. And the second significant element is the tonal patterns in classical Chinese poetry. Besides, the last type is a quite interesting one, called acrostic poetry. In detail, in terms of poetry mood, it is defined mostly by the input words, which are set as the poem theme. Since we would initially put the input words into the model, and the model after training will match the words with most likely artistic conception. Finally, we will choose the word with the highest possibility and combine them with almost the same mood as a whole poem. And this one is a unique skill in traditional Chinese poems. In 七言律诗 and 五言绝句, both of them have rules in the tones of words, which is demonstrated in this black table. I use 0 indicating level tones containing the first and the second tones, and 1 indicates oblique tones, which consist of the third and fourth tones. By applying this table in a random rate in controlling generating words, we would create a poem with a better matching skill. The third one about acrostic poetry is a process of embedding words. Use the given words to generate new words, at the same time inserting them into the corresponding location of the poem sequentially. We can get the poem such like this one. Linking the first word in every line, it is just the title of this poem. In addition, as for the future improvement, there are 2 points I want to apply in our project. For the one hand, in order to avoid generating repetitive poems, we can define a random rate, which means that 90% follow the possibility table, and in last 10% situation, we can choose the word from top 1 to top 5 in ordered table. This method is helpful to enrich the style of the poems. For the other hand, some operations should be applied to deal with the reduplicated words. Because many ancient poems stress on the integrity of antithesis, we should ensure that there is an appropriate echo or reduplicated words in 2 verses of antithesis. After finishing the generation of the poem, we want to demonstrate the poem in a way of Chinese calligraphy. Before we started, I want to say, although our AI focused on the translate the character into Chinese calligraphy, this structure can potentially be used in translating any font to another. But for our project, we choose Wang Xizhi's calligraphy style as a dataset. Just introduce Wang Xizhi in short. He is a calligrapher, writer, and a politician who lived in Jin Dynasty. In fact, Wang is sometimes regarded as the greatest Chinese calligrapher in history, especially the one showed on screen, which named Lanting Jishu, is the best in his life. When he wrote it, he was so drunk and it let him step into another world. and then he brought the landing dish back to the earth. However, his works are only written in traditional Chinese, and many Chinese characters are not being written down. Therefore, we are really looking forward to seeing his font style written in simplified Chinese. To collect his works, we found a font that made by his fan. Then, we created a list that only recorded the word written by him. For those words, we imagized them in a common font and created a 2056 x 512 pixel image for each character. The image is the one I displayed on screen. Therefore, we could use the right one as the input and left one as a ground truth. Since the testing is less important in a art-oriented project, we only use 10% of our dataset for testing and the rest for the training. Before we move to our font-to-font GAN structure, I want to briefly talk about original GAN structure for the purpose of better understanding and comparison. Generative Adversarial Network as a huge academic development is proposed by Langfellow in 2014. Different from traditional deep neural network learned from the ground truth, GAN introduced the idea of competition and evolution. GAN is made by two independent neural nets. One called generator and another one is called discriminator. Just like their name, the generator will generate a sample, and the discriminator will decide whether the input is real or not. So, for forwarding propagation, random noise will feed into the generator and let the generator generate an image. Then, this image along with other ground truth images will be fed into the discriminator. Since the discriminator gives the result of fake, the generator will learn until fool the correct version of the discriminator. Until now, the discriminator will learn from both training data and fake data. Once it can judge the fake one as fake and real one as real eventually. This process will happen again and again until the generator can produce a brilliant result. However, although it seems pretty persuasive, we still cannot use the structure in our project directly. It is because since we feed random noise into the generator, the result will be totally random. In this scenario, we can only pray for the outcome of the generator is the right character, which is no way to be used in our project. Then, if we dig deeply on other transformations of GAN like cycle GAN or AC GAN, they are pretty good at solving critical computer vision problems like face swap, generating image from text, and etc. However, Chinese character has strict principles on the shape, stroke orders, and so on. So the word that we generated may just not exist in real life at all. These two problems can be discovered in my old project that generated avatar images. You can find the avatars are totally random and some just looks like a monster. To solve the problems, we propose a novel GAN structure and we call it font-to-font GAN. There are several differences. We embed a UNet structure as a generator instead of the simple decoder. The benefit is the encoder of UNet will be concatenated to its decoder. Therefore, more key information for Chinese characters will be preserved. Then, instead of feed noisy data, we just feed the image of the Chinese character into the generator. At the same time, we also feed the ground truth into the generator. By that, the codes for ground truth and input data will be obtained, which are the output of the last layer of the encoder. For two codes, we propose the code loss, which is L2 distance between two codes. Therefore, the two codes will be similar with the transcoding. Besides that, we also used word loss, which is L1 distance between two outputs of generator and the ground truth. Finally, the generator loss will be sum of the code loss, word loss, and the Euro GAN loss. The loss for discriminator will be remain the same. As far as we know, we are the first team using code loss. So, why code loss is essential to font-to-font GAN? I want to explain it in a human's way. We know the encoder extracts the key information layer by layer. Similarly, in a human's way, the first layer forgets unique features of different font. The second layer forgets the style of the current font. The third and fourth layer forget the shapes of the current character and the order of strokes. Eventually, the code only contains the shape of the position of each stroke, which is the most essential part to make a character. Of course, neural network would not think exactly the same, but clearly, to make it similar, the code loss is the key to make generative word away from writing whatever it wants. It actually reminds me of a thing that read from 倚天屠龙记. Zhang Wuji masters Tai Chi sword in half an hour by forgetting all skills taught by Zhang Sanfeng, which is kind of performing in a similar way. The key to knowledge always hides on the ground. Here is the testing result. Clearly, more training does not mean a better result. It starts to overfit after the 200 epochs. Also, the traditional way to judge overfitting may not work well since it's art-oriented. Therefore, we vote inside the group and finally choose the 117th epoch as a generator that we use. To achieve this result, training on RTX 2080 Ti only cost around 4 hours, which is really surprised us.
We have now finished most of the training and generating part. The remaining task is to present the poem. As the text and the corresponding Chinese calligraphy images are already generated, we do a transformation from text to speech based on iFlyTech Xunfei platform. We apply for its online speech synthesis service, acquire text from our poem text file, and combine the speech voice with background music. As for the Unity part, we created multiple input boxes and buttons. The Start button delivers a command line containing parameters to run the program. After the process, we can enjoy the poem reading video in a new scene. About this project, we have some future development plans. We could apply random coefficients and improve rhyme and rhythm to make the poem sound even better. Besides, there are also some things to do to increase the poem's diversity in background images, background music, reading modes, and even multiple language support. At the end of our presentation, we need to say thanks to all the open source research resources providers. We are grateful to Dr. Desmond Chai, Dr. Cecilia Chen, for the patient instructions and hard work for the whole semester. And also thank Group 1 members Dong Guanfang, Gao Meng, Xu Peixuan, and Liu Mingkai for our work and collaboration.